Hello guys, my name is Aditya Anand and today we'll be writing a program to display all the prime numbers within a range. This is the 12th question of the 15 questions that we were solving in this series. So as I promised earlier, we'll be using Spider for some questions. So let's use Spider for this question, and after we solve this question completely, we'll run it here again on this Jupyter Notebook and we'll see that both the outputs are same. Okay, so this is the Spider software, and here we'll be writing our Python codes to print all the prime numbers within a given range. So for that purpose we need a range first of all. So suppose I'm writing a comment, okay, and suppose our range is, let me just increase the font size. Yes, suppose our range is, let's say, 5 to 10. Okay, so what can be the possible numbers within this range? That will be uh, numbers in range, that will be 5, 6, 7, 8, 9, 10, assuming that this range is inclusive of both 5 and 10. So we'll have these numbers in the range. Now we have to pick only the prime numbers out of these numbers. Okay, so how can we do that? So first we need to know what is the property of a prime number. Okay, prime number, prime number, a number that is divisible by 1 and itself. Okay, let me write this as comment here. Now it is clearly visible, right? Let me just shift this a little bit this side. Yes, so a number that is divisible by 1 and itself is called a prime number. So 5, is it divisible by 1? Yes. Is it divisible by itself? Yes, but that does not mean it is a prime number. It should not be divisible by any other number, right? Obviously, see, 5 by 6 is if we do 5 by 6, it is less than 1, right? 5 by 6 is less than 1. So, and 5 by 5 is equal to 1, is equal to 1, right? So we just need to check the numbers from 1 to 5 because division by 0 is not defined. Okay, so we just need to check the numbers from 1 to 5 which are dividing 5. If there is any number from 1 to 5 except 1 and 5 itself that is dividing 5, then 5 is not a prime number, else it is a prime number. So we will be using exactly this concept to solve this problem. I hope you are getting my point, right? Suppose let's talk about 6. First we'll check 6 divided by 0 is not defined, so it is useless to check. 6 divided by 1, it is divisible, and see, every number is divisible by 1 in itself, so we won't check even this 1 and the number 6. So we'll start from 2. Okay, 6 divided by 2, which is equal to 3, and leaving a remainder of 0, right? So if the remainder is 0, that means 6 is exactly divisible by 2, so it cannot be a prime number because it is divisible by other numbers except 1 in itself, right? So this is the logic we'll be applying and we'll be solving our problem. Okay, so let us start solving our problem. First we need a range, right? Lower bound, or let's just say L bound. let me write it full. WER lower bound, okay, is lower bound comma upper bound is equal to input, and we'll write here, yes, enter the range, okay, and the range will be separated by a space, so we need to split it. This is how we take multiple inputs in a single line. Okay, let me just wait first, let me just print this, print print lower bound and upper bound, right? uh, if you write some letters and you press tab, then it automatically fills up here as well and in Jupyter as well. Okay, so if I just write UPPE, let's say, and I press tab, and it automatically fills up. Okay, so see here we'll get whatever, this is our console. Okay, let me run this, we run it from here, so it says enter the range. Let me put the range 5 10, separated by a space, right? Separated by a space. So if I put this range, then it gives me the output 5 10, and we want to check what kind of variables are this. So this is possible in Spider. Just go to variable explorer here. See, both are of type string. One has a value 5 and one has a value 10, right? Both the lower bound and the upper bound. So we don't want it to be string. These are actually integers. So we need to typecast them into integers. How the typecasting happens is, wait, let me make this capital so that both look similar, right? Yes, lower bound is, sorry, int of lower bound, right? And upper bound is equal to int of upper bound, right? Now these things will change to integer because it is typecasted to integer, typecasted and assigned back to the same variable. Okay, so this is still string, this is also string, but these two variables, this and this becomes integer, and we'll be using this in our further program. Okay, so let me just run this, 5 and 10. Now see, okay, this variable we created earlier, you remember? No, wait, this is still here, that's why. Let me run it again, 5 and 10. So yes, these two are integer, and this variable we created earlier, so it did not got deleted. We may delete it or we may not delete using the delete keyword, so just leave it for now, and let's focus on what we are trying to do. We are not sort of memory anyway. So what we have to do is, for I in range, see, we have to iterate through all these values and check all these values one by one, right? So for I in range, lower bound to upper bound, okay, and see, if we write, this is the initialization, this is the condition up to where it should go, less than equal to, right? And this step after this we can write, but here we want, see, here we want just a step of 1, right? 5 to 6, 6 to 7, so the step is just 1, and the default is also 1, so we don't need to write it. But if we write lower bound and upper bound, it goes up to less than upper bound, right? Less than 10, it goes up to 9 only. So we will write upper bound plus 1. Okay, so this is our outer for loop, and again we'll run an inner for loop such that we'll check every number from 2 to less than that number, and we'll see if it is divisible by any number. Okay, for I in range 2 comma that particular number will be I, right? Sorry, not here. Here we'll write J. This will be a different variable. So if we are checking for 5, we have to go till 4 and we have to check, okay? So this I will be 5 for the first iteration, then for the second iteration I will be 6, so we have to go up to less than 5 and less than 6, so we can directly write I here because it will go up to less than I. Okay, now we have to see uh, if I is exactly divisible by j, that means the remainder of this division is 0, then we say that the number is not prime, else the number is prime. So for this purpose we can use the flag variable as we used to do earlier, right? We'll set a flag 0 here and we'll set flag as 1 here, but we can also set some meaningful variables, like let's say I'm writing prime, prime. Prime is a boolean variable and its value is true. Initially we assume that all the numbers are prime, but while checking this condition, if it is divisible by any other number, then we say that the number is not prime, so prime is assigned to false, right? And once, see, if 6 is divisible by 2 exactly, leaving a remainder of 0, then there is we directly know that 6 is not a prime number, and we do not need to check further like 6 is divided by 3, 6 is divided by 4, and 6 is divided by 5. We don't need to check for this because it has already violated a condition. So once it has violated a condition, we write a break here. Okay, and outside this for loop, if the prime is false, then we print if prime is equal to true, then we print the value of I, saying that I is a prime number, right? Let us check this if this works or not. Enter the range 5 and 10. So the prime numbers are 5 and 7, right? If we just, let us just comment this for now so that this thing does not come up. Let's check for 5. Just a second. Okay, fine. Let's check for 5 to 15, and it says 5, 7, 11, 13. These are all the prime numbers between 5 to 15, and it is working correctly. Okay, now see, there can be a little bit more optimized version of this thing, that we don't need to check up to less than I. If it is not divisible, see, 6, okay, 6, suppose let us consider 6, so we'll check that 6 is divisible by 2, then we'll check 6 is divisible by 3, then we'll check 6 is divisible by 4, then we check 6 is divisible by 5, right? So see, 6 divisible by 2 gives a remainder of 0. 6 divisible by 3 can also give a remainder of 0, but 6 divisible by 4 will never be 0, right? 6 divisible by 4. Similarly, if we write 8 divisible by 5, or maybe 9 divisible by 5, or maybe 10 divisible by 6, this can never be 0. These can never be 0, right? Because it is greater than the half of this number, right? It is greater than the half of this number. So if we directly do it, we don't need to check up to less than I. If we directly do integer division by 2, then it will work fine. Okay, so let me run this again. 5 to 15, same result, right? So this is a little bit more optimized version. There are other optimized version as well, like there is a divide and conquer algorithm for solving this problem, and it's much more it is much more efficient than this program, but we are not into algorithms right now, so this will work for us. Okay, this will work for us. And let me just show you how we can. I hope you understood this. If you did not understand, you can always comment down in the comment section. Okay, and I will try to solve all your queries, don't worry about that. So if we directly put this into our Jupyter Notebook, it will also run fine. See, here is our Jupyter Notebook, and if I put it here, okay, so it will also run fine here. 5, 10, 5 and 7, right? Again, if I run this cell, 5 and 15, it's fine. Let me just take another range. We are always using 5. Let's say 2 and 14. Sorry, we have to press enter here. Yes, so these are all the prime numbers. Okay, we are having a problem here. 4 is not a prime number. Yes, 4 if divided by 2 should return 0, and it should not be a prime number. All others are fine. So 2, and it should be less than 2. Okay, let's just increase this range by 1 and it will work fine. This range, because it goes up to less than a half, it should go up to at least half, right? So less than equal to half, so we have to increase it by 1 so that it goes up to exactly half. Less than half plus 1, so it goes up to exactly half. So this is the problem, and we have solved the problem, I guess. 214. Yes, the problem is solved. So this is how you can write a program to display all the prime numbers within a given range in Python. This is not actually a Python specific problem. It is more of a programming problem. In any programming language you'll find such problems, and you have these ways to solve these ways to solve it. Yes, so I hope you like the video. If you like the video, hit the like and the subscribe button, and stay tuned for more such videos, and keep practicing, guys. If you don't practice, you will forget everything. So keep practicing, and have a great day ahead. We'll see you soon. Bye bye.